In this session, all you need is the Raspberry Pi Pico. We will connect the Pico to the PC to upload the firmware, and after that, we will do something with it. Do you see the LED here? This LED is connected to GPIO 25. We will try turning it on and off. Previously, we visited the site when we updated the CircuitPython firmware for the NRF52840. If you enter this site and follow the link, you will see the Pico. Clicking on Pico, you can view the latest version of the firmware. Here you can download it in English, and there is a beta version available for those who want to use it. For now, let's download version 7.25 and update the firmware. In my case, I have now connected the Pico to the PC. Once connected, the driver is recognized just like when we used the NRF52840. Here, you can see that I just copied the downloaded firmware file, version 7.2.5, which is an UF2 file, and pasted it here. After pasting and waiting a bit, it will reconnect just like it did when we used the NRF52840. As you can see, we can now see the contents like the boot.py, the text file, and the library folder, just like we saw before. Currently, you can see version 7.2.5 here. It is indicated that we have previously operated with the main point using the Raspberry Pi, but we can also run it with the code point. Now, let's modify this code and run an example. I have opened the drive connected to the P-Core in Visual Studio Code. Here, you can see the code point, and it says, Hello World. After deleting this code, as mentioned earlier, we will control GPIO 25, where the LED is connected, first. For reference, we previously controlled it with the NRF52840, and there isn't much difference now. The commands and such are all the same, so similar content is repeated. The only significant difference is that the GPIO array is a bit different. By slightly modifying that part and altering the existing code, you can quickly control the P code. B2, B5, B6, B7, B8, B9, B10, B11, B12, B13, B14, B15, B16, B17, B18, B19, B20, B21, B22, B23, B24, B25, B26, B27, B28, B29, B30, B31, B32, B33, B34, B35, B36, B36, B37, B38, B39, B30, B31, B2, B4, 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 B. Pause for 0.2 seconds and LED value false flip. Let me check it once. As you can see now, the LED corresponding to GPIO 25 is blinking, just as I mentioned earlier. In essence, this is how it works. Essentially, just like we did before, as we have done previously, let us connect to the Python terminal and take a careful and thorough look at the various differences and changes that are present on the board. We proceed to open CircuitPython, and then open the serial monitor, enter the REPL, and when we finally hit enter, we find ourselves in, let's try calling it DR mode instead of import mode. So, it is slightly different from the NRF52840. That's why it is labeled like A0 to A3, GP0, and so on. So, while these GPIO pins and the pins that control hardware are slightly different, their functions are almost the same. So, for those who have been following along with the NRF52840, you can simply change the pin arrangement a bit and control it using the existing code. In this session, we updated the Raspberry Pi Pico's CircuitPython firmware and ran a simple example. I will return with more content next time.